lies an island where the creatures roam. A famed explorer tells me they're delicious, and yet they're hitherto unknown. You might think it sounds impossible till you've seen a carrot crawl. Kind of bargain, kind of snack. Try to catch them in your trap. Feed somebody and you'll see we are whatever we eat. Find them hiding in the sand, tearing up a ketchup patch. Come to Snack-Tooth Island and discover it's bug snacks. Ooh, it's bug snacks. Ooh, talking about bug snacks. Ooh, it's bug snacks. And if the rumor's not complete baloney, then it's the story of the century. So grab a journal, listen up, and make some new friends to solve the mystery. An expedition, 13 strong of grumpuses, who all set off, seeking out a better life on Snack-Tooth Island. They did find a tasty quest to fill the hole that many feel inside their soul. Venture deep to reach the truth, and maybe you'll learn something too. You might think it sounds impossible till you've seen a sandwich climb a wall. Kind of bargain, kind of snack. Try to catch them in your trap. Feed somebody and you'll see we are whatever we eat. Find them hiding in the sand, tearing up a ketchup patch. Come to Snack-Tooth Island and discover it's bug snacks. It's bug snacks. Talking about bug snacks. It's bug snacks. Everyone's talking about bug snacks. Bug snacks.
All right. Okay. Hello, everyone. Welcome. So I actually want to take a little poll in the chat. How many of you are here specifically for session number 2, beginning at 2:30? And how many of you are just kind of hanging out? You haven't closed the tab yet after watching the first session. Oh, great. That's fantastic. We've got a lot of people here for session 2. A disclaimer. Session 2 is usually a little bit more polished than the first one, which has elements of improv in it. However, it features a messed up voice and often a little bit less time. We start a little bit late because we run late in the first session. That pushes us back in the second. And so I apologize for any differences from the first session. But there's some advantages, too, to going at this time, right? 2:30 is a pretty cool time to be watching a lecture, I think. Not right in the middle of lunch, you know? All right. So let's go through some announcements first. I'll make my window small. How did it go? How did the Tutorial 1 and Tutorial 2 assignments go? Did they go okay? I know for a fact there were, yeah, and you know who you are, there were a few all-nighters that took place. Okay, and that's not the kind of business we're going for. That is going to prove very self-destructive when it comes to Project 1, Project 2, when things get a little bit more challenging and there's more to do, all right? Really fun, still confused about fixed update and update. Fixed update is oriented around the physics engine, which does not update at the same time as the rendering engine in Unity. So you've got rendering and scripting, which happens 60 times per second. You've got fixed update and physics and collisions, which update 50 times per second. These are not necessarily in sync, so if you need to do stuff related to physics, you put it in fixed update. If you need to do stuff related to controls or rendering, you put it in update, okay? Flappy Bird was fun. Took longer than an estimated time. A lot of students say that, but then a lot of students say it took less. It's very, very hard to figure out what the estimated time should be. Interesting. T1 took longer for me than T2. A lot of people say that as well. But I see a lot of demos put RB manipulations in update. You can totally do that. It's totally fine if you do that. Yeah, I didn't take installing Unity and setting up the environment into account for the first tutorial. Yeah, Unity installation can be a little bit tricky. Unity as an ecosystem, they're strange. So some tech stacks, their entire purpose for being is to be backward compatible and be very stable. So Microsoft is pretty well known in the corporate world for being a very stable enterprise partner because that's what businesses, big corporate businesses, value, right? You're not going to break anything. If I get the new update, we're going to be fine. It's going to be backward compatible. It's going to be stable. It's going to work, right? And you're going to support this forever, right? We're going to use Windows XP for decades after you've stopped updating it with security patches you're releasing. Unity is not one of those orgs, okay? They value innovation over anything else. They are totally fine with breaking the new build, okay, and breaking your code. And so with Unity, you get very used to, oops, this version of Unity just flat out doesn't work. Okay, well, I guess I'll go back to the old one, or I'll just update to the new beta version of whatever new is coming out, right? And so you'll get very used to instability in Unity's ecosystem. But in return for that, there are a lot of new features coming out all the time, and it is a very impressive ecosystem once you get deep into it. But, okay. And then supplemental, it's hard to finish faster than time videos because you have to do code along. Yep. Installing Unity, setting. Okay, cool. All right. I'm glad it went well for you. But a few things to talk about. If you were one of those people who stayed up late until 2 a.m., 3 a.m. to finish these assignments, you need to ask yourself now why. Okay? Was it a scheduling issue? Was it a procrastination issue? No matter what it was, there's a technique that can help you get past it. Okay? And you need to figure this out, and you need to work on it so that you can be more productive, be impactful, and get through this course keeping yourself healthy. Okay? A little bit of motivation that connects with this. If you think about the most productive people that you know, if you think about the lead in your research group, or maybe there's a manager you really expected an internship, people who seem to be doing a ton of things, but they're very calm and collected, right? It doesn't seem to affect them. In many cases, they look calm and collected. They look like they're taking it easy, but they're just underneath and behind the scenes, they're doing so much stuff. Well, you too can do this if you get better and better at your time management techniques, okay? So I'd like to give you an example of one, okay? And this is something I learned at Electronic Arts. So at Electronic Arts, I jumped onto the code base of The Sims 4 toward the end of development. They had been working on the game for about 4 years at the time. And the game had about 4 to 5 million lines of code. And so, being the dumb new hire that I was, I thought that, okay, a computer scientist, right? We kind of work alone, and we jump into a code base, we understand it, we get used to it, and then we navigate it and fix all the issues. And that's not at all how it works, okay? When you have a code base that big, you can't solve a problem in someone else's system without going and talking to that person. So here's how it goes. You get a bug report, and it has to deal with some other system, the player manager. Okay. You have no idea how the player manager works. You look at the player manager code, it makes no sense to you at all. You have no idea why these lines are here and what they do. And so, you might have a rough idea, but you don't know the specifics well enough to solve the bug. So, instead of just sitting there and spending 4 or 5 hours and being blocked and pounding your head against the wall, right? That's time you're burning. You need to solve the bug as efficiently as possible. So here's what you do. You find out who owns this system, who's the expert in the player manager, who wrote it initially. And then you find them and you grab 5 minutes of their time. You say, hey, the player manager is behaving a little bit weirdly. When this happens in game, it does this erroneous thing. What do you think I should do? They go, oh, I know what you should do. Okay, this is an issue with the timing here. The timing issue, you should look at this file, this function, okay? And you're like, thank you. Then you go solve the issue in 30 minutes instead of 4 hours, okay? When you get blocked on a problem, you spend only spend 15 minutes in this course on that problem. Start a timer. If 15 minutes go by and you haven't made any progress at all and you don't have any idea on what to do, you stop working on that problem. Don't let it block you. You take that problem to Piazza. Chat, has anyone taken 482? Has anyone taken 482? Any 482 fans? What a great course. Spectacular course. Peter Chen has done an incredible job with it. What you do in that situation, right, is you spawn a new thread, if you can. You spawn a new thread, you go do some other work, okay? Let that other thread handle it. In this course, when you get blocked, you try and get it done, but if you can't, quickly, you throw it onto a second thread. You throw it onto Piazza, where the entire course can start thinking about it to help you out, okay? Your instructors can start thinking about it to help you out. And then while you're working on something else, boom, suddenly the solution comes through on Piazza, or you get a really good idea on Piazza. Then think about it. You have spent very little of your own time solving that problem, and then suddenly the solution comes in. You want to spend 4 hours on that, or 30 minutes writing it up, putting it on Piazza, and then a quick 15-minute fix, right? That is a difference of like 2 or 3 hours. Those 2 or 3 hours could be the difference between you staying up very late or you getting a decent night of sleep. That could be the difference in this course. This course is literally designed to put pressure on your time so that you have to make difficult time management decisions, from getting rid of tasks and deciding you're just going to not do them, which is totally acceptable. You'll lose a little bit of points, but you do the math, right? Is it worth it? And you doing techniques like this, right? When you get blocked, quickly, get rid of your pride, quickly throw that task up onto Piazza, and if it still can't get solved, you take it to office hours where we can knock it down quickly. So that is an example of a technique that you absolutely need to do, all right? And there are others as well. We'll talk about them a bit later. Okay, graduate students. Any graduate students in the crowd, you need to contact ugaadmin@eeks.umis.edu if you're not in the course yet. Usually, we can get you a seat. 494 typically does not fill up because it's a very difficult course. However, keep that in mind. This is designed for undergraduates and their workloads. It might not fit into the workload of a busy researcher in grad school, okay? So keep that in mind. There's some submission tips. When you go to submit your game or your assignments, whenever you submit anything in this course to Canvas, always download what you submitted and verify that you submitted what you think you did. Because every single semester, we get teams that submit like a previous assignment. They finish tutorial 2, but they submit tutorial 1 because they accidentally misclick. Well, a few days go by, it's no longer possible to turn something in, even late, and we don't have your stuff. So that's a 0, and there's really no way back. You're not getting those points back unless you do a ton of extra credit, and there is quite a bit of it. But so please be very careful, okay? Another thing, you always want to do a safety submit, okay? So due to our late policy, it's very simple, but it's also, compared to other courses, it's pretty strict, okay? If you are a second late, or even if you're on time, okay, having that time stamp perfectly match up on Canvas is considered late on Canvas, is 20% off, okay? Submit your builds early so that if you need to, you can just, hey, grade that early submission, right? It might be missing a couple bug fixes, but at least it's in, right? It's in on time, so it's not going to get the 20% penalty. Okay, let's keep going. The toughest stretch of this course begins in 2 days, okay? With the launch of Project 1. Project 1, the end of Project 1, signifies essentially the end of the hardest part of the course. Project 2 is really nice. It's a breath of fresh air for almost everyone because you get to decide what you're creating, which means that you can choose a design that's a little bit lighter if you want to. You can choose a design that you're really passionate about, and that makes everything so much easier. If you look at it, Project 1 begins on Wednesday and ends like in mid-February. So the 15th. Can you make it to the 15th? What is that, around 20 days? It's not super long, but it does feel that way because of how difficult that stretch is. We know you can do it. Please rest up in the next 2 days or so and mentally prepare for a nice, healthy sprint, okay? It won't be too bad if you use the techniques we just talked about, but it can be if you don't. Okay, so one thing that's due Wednesday is the P1 team registration. I'll remind you, it is this form right here in which you decide which game you want to work on and what partner you want to work on with. If you do not have a team of 2, one will be created for you. However, if you want to decide what game you work on and what partner you have, you'll want to fill this out, okay? No worries if you don't. A lot of students do random teams in this course, and it often goes very well. Sometimes it does not, but... a word of advice on this topic. Controlling your roster is really, really important. Okay, I'll ask another question I'll ask another question, and then I see a question I'll answer in chat. How many of you in high school or earlier in your college career got onto project teams where it is very clear there's a freeloader on this team, and it is very clear that maybe you are the only one who is passionate, and this fact means that no one else will help you because they know that you will strive for the A, which means you'll do it all. It's kind of a prisoner's dilemma in a way. You have that feeling? It's a really bad feeling, okay? It's a really, really bad feeling, and it's a very bad situation because four people's worth of work will fall on you, and you won't get 4 people's worth of ideas. When a team is working really well, you get X number of people times the number of ideas, diverse ideas that you can get from all of them. You also get that amount of effort from them. So the amount you can accomplish and the amount of insight you can get and inspiration you can get absolutely explodes. However, the opposite is kind of a problem as well. Because if you have 4 people on your team, but really only one of them is working, you have 1 person's worth of ideas, and you have 1 person's worth of work, whereas 4 people's worth might be expected. It's a pain in the butt. Anyway, this is to say that controlling your roster is really, really, really important. It's one of the most important things you can do when you get into industry, when you get into academia. Choosing what team you go on to. If you can't control your roster, you can control what roster you join as a means of controlling who you work with. It's extremely important that you vet the stuff, think about it, right? And do your best to manage it. It's really hard to do on P1 because you can't really vet any of your potential teammates. You don't have their portfolios don't have anything in them. For P3 though, hey, it's just business, don't be offended, but you better show me your P2. You better show me your P1, okay? You better tell me who you worked with. Because it's going to be pretty obvious who you want to work with and who you don't. Anyway, that's why I'm in a startup right now. It was very important to me that I manage my roster, and thus far it's been a very good choice. Okay, so anyway, let's keep going. Project 1 demo video. I'm going to show you. I'm going to get you hyped for P3 next time. Okay. Okay, let's talk about a fun topic. Oh, there's a question. How much of it are we going to be prepared to attempt of it immediately? I think you're probably talking about Project 1 and the classic game. The first deliverable of Project 1 lasts for 5 days, and essentially you implement one of everything in the game. You implement one weapon, you implement one enemy, you implement the ability to transition between rooms, you implement, I think, an item or two, and then in the second, the alpha sprint, which is like 14 days, I think, something like that, you implement the rest of all that stuff. So, can we use Find a Team channel? Of course. Oh yeah, that's what it's for. I am the freeloader. You don't want to be a freeloader in this course. You'll understand why in just a bit. We have means of finding you and punishing you for that. Okay. So every lecture we like to talk and study something about an actual physical tangible game. You just turned in a bunch of platformers starring rolling balls, okay? And a lot of them, looked a little bit similar to this, except the way that shadows work. Students for tutorial 1, because it's not a requirement, they often don't change the way that shadows work. As a result, are we lagging a bit? As a result, I think we're good. As a result, it can be really hard to platform in many of these rollerball games that you submit. Why? Because your shadows work differently. Your shadows are often off and angled off to the side. So when you jump, your shadow like slides out sideways from underneath you. It makes it hard to understand where you are in 3D space. Shadows are extremely important because it's a cue that helps the brain understand a 3D space from a 2D representation. Remember, your screen is literally just a 2D array of pixels, but your brain has to figure out and understand a 3D space from that 2D image. It's very hard. So the shadow is used to do this. Using the shadow, we can pretty easily understand where we're going to land in this example, right? And we can understand when we need to go further, when we need to stop. It's good stuff. Let me restart here. I'm going to restart, and I'm going to turn shadows off. And what you'll notice is that your brain probably starts to hurt just looking at this a little bit. There's a little bit of friction. In part because you don't know, your brain has to guess where you're going to land, and sometimes it's wrong. You can sort of guess where you're going to land because usually it's the center of the screen, but not always and not precisely, okay? Oh, that looked like I was going to land perfectly, right? Because of the lack of shadow, it doesn't. Yeah, VR and augmented reality does help fix this problem. So in real life, your eyes are offset, which allows them to really easily judge distance. Because they're in different space, right? They're in a different place. Your brain takes those two different images and basically checks the difference between them to determine depth. You can't do that when you're looking at a 2D image. So you have to look at shadows instead. VR solves the problem. It emulates real life because you have two different lenses. They're both offset a little bit. And suddenly you can see depth and judge it really easily. Anyway, let's watch how AAA studios deal with shadows. I'm going to show you a game, Crash Bandicoot, the Insane Trilogy. This is a game that looks incredible, but it does something really interesting with the shadows that's really weird and surprising once you notice. I want you to watch this footage and look very closely at the shadow and how the shadow for the player character works in this game. And I'll ask you a question right away. How many shadows does the main character have? You would think just one, right? It's only one sun, right? We're being chased by a boulder. Chat, what do you notice? Anything weird about this shadow? It's a good-looking shadow. Bingo. Mopey nailed it. Well done, well done. There are two shadows in this game. Two shadows. One is used as a marker, and the other is the actual shadow, the model. Bingo, you got it, Evanir. Okay, so I think you can see this really prominently early on. And on slopes, you can see this really well. Are we gonna have it? Okay, you can see it faintly right here. So this game uses a dual shadow approach. One shadow is meant to be realistic and beautiful, right? It accurately shows what the shadow, the 3D model would cast in its current point in the animation. The thing is, though, it's also angled, so it's not as useful in helping the brain judge depth and figure out where Crash Bandicoot is in this 3D scene. That's really important because this is a really tough 3D platformer. And so what you'll notice is that the game always, no matter what, sends one shadow downward that is not a shadow. It's actually just a decal. It is just a dot, a faded dot that's always beneath the player on a surface, no matter what, okay? And this helps the player understand where they are in 3D space. If you want more proof of this, I'll ask you this question. Have you ever seen a shadow be cast on thin air before? On thin air. I don't think that's usually how shadows work in real life. But in Crash Bandicoot, whoa, do you see that right there? Are you seeing that? Chat, are you seeing that? Okay. That's not how shadows work. However, in this game, it was so important to help the players out, help them understand and judge 3D depth with precision platforming, that the designers decided on this hybrid approach where they would put in a fake shadow for gameplay purposes, and for realism and immersion purposes, they would put in the realistic shadow, okay? And so it is, yeah, it's pretty cool. Now, there is an argument that could be made that they put fog down here, and like, okay, you can sort of see shadows when the air isn't, like, clear. Yeah, I'm not really buying that, though. There isn't nearly enough of it here to cause that thick of a shadow to be seen. But anyway, it's just a really fun example of how important shadows are in games like the rollerball you made. And here's an example from Crash Bandicoot 4, the most recent in the series. They decided, you know, enough with this. We're just gonna take a highlighter to your shadow. Watch this. Do you see that? Did you see that, chat? It is literally a circle. A yellow circle that just raycasts downward and gets painted. It is not very subtle, but it's really effective though. See that? There you go. Okay, and that helped a lot of players out, helped them understand where they are in the 3D space. So, okay. All right, so let's go ahead and keep going. This may feel like a tangent, but this is to say that in game design, there's often a tug of war between realism and immersion. You want a place to feel realistic and lifelike, and accessibility and a gameplay, right? Where you need to impart certain information to the players simply because of limitations of the medium, right? A 2D screen struggles to represent 3D space. So keep that in mind. There's lots of little things that designers do sort of like this to help the player out, and you'll need to do some stuff like this as well. Okay, so let's go through some course logistics. This might be considered the meat of the second lecture. Normally this stuff would be on the first lecture, and it is important, but not important enough to do in the first day. I also find it kind of boring. Don't want to bore you on the first day. No good game, no good movie does that. So, all right, who's heard of who has seen this scene before? It's a really, really great clip from SpongeBob on the topic of logistics, what it can feel like when it goes wrong.
What's his name? What's his name? I got nothing on a name. Come on, baby, what's the name? We threw out his name!
All right, so that is logistics gone wrong. Let's go ahead and go over some grading-related topics and policy-related topics so that this doesn't turn into 494. Okay, 494 doesn't turn into it. Okay, lectures. So lectures take place 12:30 to 2:30 p.m. Eastern Standard Time, and also 2:30 to 4:30 p.m., as you know. You can go to either of these. They're both on twitch.tv, ARGR, and they're both recorded to YouTube a couple days after the fact. You can watch them on Twitch during that time before they get on YouTube. There are several different lecture types in this course. So first is our standard lecture. It covers history of game dev topics, theory, design, discussions, stories often. We have another type of lecture where it's more of a workshop, where we'll spend a big block of time, 30 to 60 minutes, just implementing some sort of system. We'll build out a system to show you how a design pattern or a piece of technology can be used in a really effective way. And it's very interesting because some students really prefer these more high-level lectures to the nitty-gritty workshops, which can lose attention, and some people the exact opposite. They really like to see the engineering happen in front of them. And so look forward to this variety at the very least. Later on in the course, we'll have entire lectures dedicated to playtesting, where you will be given a block of time to play the peer games and peer projects of your friends, your teammates, not your teammates, the other people in the class. And you'll essentially be recording video footage through OBS or something of you playing the game, reacting to it, and giving feedback, articulate and detailed feedback like a YouTuber. So look forward to that. It's very, very fun. The end result of this, during Project 3, every single week, you will get over 4 hours of recorded footage of your classmates playing your game and giving feedback. Extremely valuable data for deciding what you want to change and tweak and balance every week. So look forward to it. We also tend to have guest lectures in this course. I think last semester we had the Atari Vice President, John Hayas. And it's always great to get such visceral knowledge and experience and wisdom from people who are right in the thick of it. So look forward to that. The final lecture type is usually kept a surprise because it's my favorite. Unfortunately, though, it is a victim of the pandemic. Field trips. Unfortunately, this semester we can't do field trips to Pinball Pete's. No field trips to Ann Arbor Spark. No field trips to the CVGA. It's dark times, you know. But that's okay. That's okay. We'll still have a lot of fun in this course. And then maybe you can audit and join us when we return to campus, and I'll give you a few quarters at Pinball Pete's if you do that. So, okay, let's go over the schedule real quick. A reminder: the first part of our course is about engineering a game. How do you make a game run, basically? The next part is about design. How do you make a game that is engaging? And then the final part of this course focuses on getting both a very workable and functional game that's also engaging to play and scalable, so it's a bit bigger, okay? Let's talk about grading. This course has 872 points of it from what I calculated last night. It's around that number, at the very least. Each point is worth about 0.1% of your grade. This does not include extra credit, which there's quite a bit of in this course. So if you did happen to mess up Tutorial 1, Tutorial 2, and you got a bit of a gap already, don't worry about it too much. You should be able to make at least a part of that back later on in the course fairly easily. Here are the assignment values. Your Tutorial 1 is 40 points, around 5% of your grade. Your Tutorial 2 is about 60 points, 7% of your grade. If you're wondering why these assignments are so valuable, it's to get you a lot of points. It's to help you in your grade out. It takes pressure off the rest of the assignments, okay? So make sure you get those points. Hundreds, and even if you're late, even if you haven't turned stuff in yet, turn it in. Find a way to turn that stuff in, get a lot of those points. Don't miss out on all of them. That'd be really bad. Project 1 is 170 points, works out to around 20% of your grade. And Project 2 is a little bit less, at about 17% of your grade. Okay? Project 3 is where the big batch of points is. I don't think that'll surprise you. It is the longest assignment. It has the most kind of sub-deliverables inside of it. You don't have to worry. This isn't a final submission. You get points. As you do these projects, you get points for each deliverable, and the number of points goes up. So if you're struggling early in a project, you can still get most of the points as long as you're rolling by the last few submissions, okay? And then 30 points, 3% of your grade is participation. A caveat with this participation grade, it can go negative, okay? So participation points are, in remote semesters, they're almost always only lost by people who skip playtesting sessions, which you should not do. that compromises other people's experience in the course. They can't get feedback, they can't improve their game. And if you slack, right? If you are identified as a freeloader on your team through your peer evaluations and through your Jira site literally saying that, wow, you've put in like less than 50% of the number of hours your teammates have on average, then you are going to lose either 25% of all the points your team has earned on that project or 50% if it's particularly egregious. And so you do not want to be a freeloader in this course. Please dedicate the time to it. Note, just because you can't dedicate time or don't dedicate time to your project doesn't mean you're freeloading, right? Sometimes this happens because of medical issues. Sometimes this happens because of family issues. You have a week or two where you just can't contribute very much, and you got a really understandable explanation why. It's important that you tell your teammates about this. They'll forgive you. Tell your instructors about this so that when our bots flag this in the Jira system, we don't go, oh, we got another one, right? And you'll be fine, okay? This is not something to worry about. Just roughly keep up and try and contribute roughly at the level your teammates are, and you'll be just fine, okay? No worries at all. Okay. Extra credit. There are many opportunities and they don't affect the curve. So don't worry about other people doing extra credit. It's not gonna, there isn't any curve in this course, so it couldn't be effective. The average grade in this course historically is an A- or an A. It's right in that range, and this is not the kind of course. Okay, question everyone. How many of you have ever been in the situation where you're doing a course and you're knocking the projects out of the park? You're putting in a lot of time and effort into these. You feel good. You get to the exam. Boom, you just get rocked. You work so hard on the projects, you get rocked by the exam, and your grade falls apart. That was me when I was going through undergrad. Yeah? Well, every EECS class, not this EECS class, not this one. So this is a course where if you put in the time, and if you listen to feedback and use the techniques we were talking about, then you're going to be fine. You're going to get a good grade. Right? There are no exams that are going to come out of nowhere and knock you on your butt. Okay? You're going to be fine. So anyway, but you do need to put in that time. You need to be very, very disciplined in how you use the techniques we dole out. Okay? The grading process, grading a video game can be seen as kind of subjective. We all bring our different biases and different genre knowledge to the grading of these projects, particularly in P3. So to get past this a little bit, to combine all of our knowledge, the graders, the 4 graders in your course, will essentially combine their grades on Project 3. We all play your game together, give feedback together, and then we debate what your grade for each criterion should be. And so you don't have to worry about, like, oh, Austin's really into horror games, or Ishwar really loves music games. We all have a broad knowledge of games and genres, and we mix that knowledge to get the best and most standardized and objective result we can for you. Okay. Collaboration policy on T1 and T2 and P2. P1. On these early assignments, you are not allowed to share anything. You're not allowed to use stuff on the internet. You're not allowed to copy stuff in, stuff like that, okay? This must be pretty standard. This is the policy you're probably used to from other courses. However, on other projects like P2 and P3, you are making a unique game that no one else in the course is making, probably. And so external assets are allowed. You can bring in assets from the internet. You just need to credit them. You put the link to them in credits.txt so we know what you made and what you didn't. You're not allowed to download entire projects. You need to keep this quantity somewhat small, but you can do it. And you're allowed to talk about code in your game with other people because they're not making your same game, right? So each assignment spec has a top section that has explicit rules where it will outlaw certain things, ban certain things. So make sure you read each spec very carefully. We use Stanford's software to detect code duplication, and we get about 1 team every year. So please don't try. You're really going to put yourself behind for P2 and P3 if you do that on P1. So don't do it. Okay. In this course, in general, you may discuss course concepts at a high level. You can even discuss assignments at a high level. But sharing code for your specific assignments, do not share code. However, if you want to, explore a particular concept, like the concept of raycasting with a friend in this course, you can create a new project. Create a new project that has some weird raycasting experiments in it. See if you can figure out what's going on together. It's a really good idea. So you can share code and work on projects together to explore general concepts. Okay? Do not share project-specific code. Okay? We don't want to go through that. You may use external assets on P2 and P3, but only in small quantities. Only if most of your project's assets were created by you, and only if you document your usage. Okay? You have to tell us who made it, where we can find it, and you also need to make sure you have a license for the assets. We'll warn you if we notice something in your game that you don't have a license to. And here's what we're talking about. If you submit something to us that has Mario in it, we're not going to be very happy. Okay? We're going to tell you to get rid of it. And if it's still around in the next deliverable, we're going to penalize you pretty harshly. Okay? You do not have a license for certain things. You do not have a license to put Mario or Crash Bandicoot in your game. What is a license? If you go to any code repository, you will find this, license.txt. And inside of this is basically a block of text that tells you what you're allowed to do. Okay? It could be something like the BSD license, right? Which OpenVPN uses, and that basically lets you do anything with it. You can edit the code, you can sell the code. There are other licenses out there, like public domain, which lets you do anything too. There are licenses like GPL, which would terrify businesses, but you probably don't care very much about. It just means you have to make your code public if you make any changes to it. However, if you can't find the license for something, then you should not use it. Right? If you go on Google image search and just search for Mario, you're not going to find a license for that because Nintendo's not giving out licenses. You can't use it, okay? You can use anything on the asset store, essentially, but do not download entire games. We've seen a bunch of them. We'll notice, and that'll be really bad, okay? Okay, any questions? Yes, each project is a string of assignments and deliverables that are all related, but one after another. So, okay, let's keep going. Participation. Must you attend every lecture? The answer is usually yes, not anymore because of COVID. Must you attend every lecture on time? No, it doesn't apply to you. There's no penalty for doing this. We don't take attendance because we can't. Almost none of this is relevant to you. Okay, cool. Where can I see lecture captures? Twitch.tv/ayarger is going to have it for you. We also have links on YouTube. This one, I think, is pointing to the last semester's link, but go on Canvas and you'll find a link up to date to the YouTube playlist for the semester, okay? When are things due? Typically at the beginning of the first session, so 12:30 p.m. Eastern Standard Time in our case. Keep an eye on Piazza and Discord because we do a lot of announcements on those two. And sometimes an announcement will be one place but not the other. So please keep an eye on both, okay? Wait, so we do attendance sometimes? No. During in-person semesters, we do take attendance. However, we do not during remote semesters. It would be impractical and also very unfair logistically. Not every student can watch our lectures at 2:30 a.m. in their time zone, where their home is. So we don't want them to have to do that. It's just not reasonable at all. Okay, the late policy is super simple in this course. You've got 24 hours after the deadline to turn it in for a 20% deduction. Here's some Python code to explain it to you. After 24 hours of lateness, we're just not going to grade it, okay? So get your submissions in. It doesn't matter if it's not finished yet. You can submit it as many times as you want. Submit something early, and I mean like a day, 24 hours early. If disaster strikes, there's a good chance you can avoid that 20% penalty by just rolling with your earlier submission. Yeah, there's going to be a few more bugs, but it's probably not going to add up to 20%, right? you'll have to make that judgment call. Yeah, make sure you don't get that 0. That 0 is super painful, and it's bad. Okay, extra credit can help you out there, but you don't want to do that. What's the official timekeeper? It's Canvas's assignment submission timestamp. And understand, Canvas considers something submitted at the exact time, like the exact minute of the deadline, to be late. And we will too, okay? So make sure it gets in before that deadline. What if Canvas is down? If it's down for everyone, a widespread outage will delay the assignment. If it's down just for you, like your internet at that moment decides to not want to upload something, or it uploads slowly, hey, you have so much time in which you can upload stuff. We ask you to upload early to be safe. We're not going to give you any sort of leniency there, okay? So make sure you get your stuff in early. Redundancy and good habits can prevent all these penalties very easily, okay? Okay. This course has a ton of office hours, okay? We have office hours almost every day. And we have some other stuff I'll tell you about in a sec. The chain of help that we talked about at the beginning is this. Okay, you run into an issue. Spend 15 minutes experimenting with the issue and Googling how to get past it. If you make 0 progress, you move to Piazza. If you make a little bit of progress, reset the timer. Post to Piazza, work on something else so you can be efficient with your time. And then if Piazza can't help you, then you attend office hours, okay? And we'll try and knock it down together. This will often happen if the issue is something we haven't seen before and we need to look at your code base. We'll usually tell you to attend office hours, okay? You can do private correspondence with us via email, 494staff@umich.edu or Piazza. There are other ways to get pseudo office hours this semester. Wolverine Soft is a fabulous club that has a lot of very, very knowledgeable and talented students who've already taken the course and who have put out big productions through Wolverine Soft Studio. They can help you on any kind of high-level or general concepts you have, and they can even help you with your code on P2 and P3, so long as they're not writing all of it or most of it, just kind of helping you edit your code. There is no EECS 494 public game night anymore. We might revive it eventually. When it comes to health, managing your health, right, your physical health, your mental health, is a humongous part of this course. It's very, very important that you get some sleep, that you get your sleep, that you eat 3 meals a day, that you take care of yourself so that you can be productive and make good use of your time. This sometimes means taking a break. Just say, hey, I'm not going to do any 494 today, okay? But you want to be very deliberate in your planning, and you want to make sure that you do this via a schedule, okay? And not just I don't feel like doing it today. If you're having troubles, if you feel your mental health is slipping a bit, you're not feeling very good, you're a bit depressed, please let us know, okay? Your instructors can help you, can offer you tips and techniques to help you get past it and through it. We can put your mind at ease, help you get perspective on, how much do these points really matter? In many cases, they don't nearly as much as it feels. CAPS is well suited to helping you as well, so please look into them if you need it, okay? However, EECS 494 rule number 1 is communicate. We cannot help you as the instructional staff with problems, discomforts, feedback, struggles that we don't know about. So don't let pride get in the way. Let us know about issues right away, okay? So that we can help you out and we can do our job. Thank you so much. And even the tough parts of this schedule, I guarantee we'll get through it and emerge way stronger at the other side when we do, okay? We'll work together. Okay, we got a couple questions. For getting help in office hours, is there any specific IDEs? IDEs aren't super important, I don't think. Visual Studio Code and Visual Studio are really effective and very, very popular. Can you have an announcement-specific channel Discord? That's not a bad idea. Ish, can you look into that? So public domain, we can use them freely. Yes. But not on Tutorial 1, Tutorial 2, or Project 1. Okay? Okay. Let's keep going. So those are the course logistics, the most important parts anyway. I encourage you to review the syllabus while my voice is really going. It's gonna be nasty on Wednesday. Okay, What I want to do for the rest of our time is I want to go through a little Unity systems tour. There are a few interesting concepts in Unity that can trip you up as you're getting started, a little bit complicated and unintuitive, and I'd like to get us through some of those, in particular collisions and coroutines today. Then on Wednesday, I would like to talk about composition, which is a really, really cool kind of a rival to inheritance as a form of code reuse. It is also kind of the foundational building block of Unity, right? You write scripts. Those scripts are literally new components, and those components can be put on various game objects and combined on various game objects to make things happen. So we'll talk about that on Wednesday. Okay, let's go ahead and talk about collisions and triggers. Okay, so as far as physics and collisions go in Unity, there are two different kinds of components you need to care about. Rigid bodies, which you've seen before, and colliders, which you've seen multiple types of before. You might have noticed that if you clicked on a sphere in your rollerball, then you noticed it probably has a sphere collider, okay? If you clicked on a rectangular prism, sort of like a piece of ground, a ground tile, then you probably had a box collider, okay? If you made a quad, then maybe you had a mesh collider or something like that. Things that moved, things that had to have physics, accelerate, have gravity, have velocity, angular velocity, mass, those objects, like your player character, tended to have a rigid body component because that's what the rigid body does. It gives physical properties to whatever game object that you put it on. I have a challenge for you, chat. Let's see how you do, okay? The first section did a really, really good job at this. Probably the best job I've ever seen on this lecture. Okay, so I've got a question. In this simple scene, we have a sphere and a kind of a rectangular prism game object, one acting as the ground and one acting as a player that needs to fall onto the ground, okay? So if you click on the sphere and then look into the inspector, what you'll notice is that the sphere has three components. It has a transform component, it has a mesh filter component, and it also has a mesh render component, okay? If you're confused about what the mesh filter is, it's a really weird name, isn't it? A mesh filter component is essentially a component that just holds our vertices for us, the vertices in our 3D model, okay? So this mesh filter holds all the vertices composing our sphere, and then the mesh render, in order to draw something, looks at the mesh filter, says, oh, thank you for those vertices, let's draw. And it does, okay? So don't worry about mesh filter too much. If you got 3D stuff going on, you're going to have one. That's all you really need to know. Okay, if you click on the ground here, that game object has three very similar components, okay? It has a transform component, like all game objects. It has a cube mesh filter instead of a sphere one, and it has a mesh render just like the sphere. So the question for you, chat, what is going to happen when we run this game? And I'll give you about 30 seconds to decide. Place your votes, place your bets. Nothing. Nothing. The objects will float doing nothing. All right, well done. Nothing. Absolutely nothing, in fact. Because remember, a rigid body gives a game object physics. A collider lets collisions happen on that game object. Yeah, and these have none. These are super basic game objects that really don't have any interesting components on them. So they don't do anything interesting as a result. Okay, I've made a change here, all right? I see the problem we had. I've made an update for you. Okay. So what has changed? Well, we've given the sphere a rigid body, and we've given the ground a rigid body because we want physics to happen, right? We want to land on the ground. So what's going to happen when we run? They both fall. Oh my gosh, you're on fire, chat. Well done. Okay, so here's the question for you, chat. Are these things falling, or is my camera going upward? Those questions that just keep you up at night, you know? Anyway, let's keep going. All right. So, I made some changes, right? I got your feedback, and I've made some changes for you. Okay, so the ground's no longer going to fall because we took the rigid body off, right? Okay, so what's going to happen? I'll make myself invisible. Okay, we took the rigid body off the ground, so it's not going to fall. It's going to land. It's going to land, right? But the sphere falls through. Okay. Okay. Yeah, you got me. You got me. It's still incorrect. The sphere goes right through it. Okay, fine. I'll fix it. Okay, we put a box collider on the ground. Okay, what do we got, chat? We got your box collider. What more do you want? Wait, it's going to fall through. How can it fall through? We got a box collider on the ground. Bingo. It still does. Because remember, the sphere might have things like acceleration and rigid body and physical properties, but it doesn't have collisions. It doesn't have collisions because the physics system, it doesn't know whether the sphere is supposed to be represented via a sphere collision or a box collision. Like, what shape is this thing supposed to be? Is it a capsule collider? Is it a mesh collider? It has nothing, so it can't collide with anything, despite the fact that it has other physical properties like velocity, gravity, etc., etc. Okay? Okay, so let's do this. Let's go ahead, and I've added a sphere collider onto our sphere. Okay? So what's going to happen? Do we have another fade through? Oh, so this time it's gonna work. Oh, let's look. Hey, there we go. That's it. The ball falls on the ground and lands. So well done, team. Well done. You nailed it. So question for you: what would happen if we took the sphere collider off of here? We clicked on this little gear, said remove component, and we put on a box collider. What would happen if we replaced the sphere collider with a box collider? It would still land, the same thing, but then what if we tilted the land? What if we tilted this land? Would it roll like a sphere normally would? Bingo. It would behave like a box. So if we gave this a box collider and then tilted this ground, it would slide a little bit maybe, but it would move down the slope like a box sliding down it and not a ball rolling. Okay? All right, cool. So that goes to show that the way the physics engine sees an object is not always the way that we see an object. The rendering of an object is separate from the physics of that object and the collisions of that object. So keep that in mind. So many things about a game object, from collisions to how it's rendered, are controlled simply based on what components are currently on it. You could write your own collider component if you wanted to, though there are quite a few good built-in ones that we can just use. Okay, so we're going to take a break in about 3 minutes. But before we get there, I want to show you some footage. And if you play a lot of games, it might hurt your soul. Okay, I want you to explain to me what is wrong with what I'm about to show you. Okay, and I'll vocalize it to give you a little hint. Okay, at what is wrong. We've got a rollerball here. I'm gonna go grab this juicy collectible. Okay, we're gonna go in. Okay, gonna grab this one and oh, okay, come on, okay, man. All right, here we go. And okay, what's the problem here? Ask yourself this question. In about 5 minutes, we're going to come back and answer it, okay? All right, go ahead and take a break. Get a glass of water. I should get a glass of water. Go to the restroom or something, and we'll see you in about 5 minutes. Let's get some music going. Oh, if anyone knows what this song is from, I'll be very impressed. This is an oldie, an obscure oldie, but a goodie. Chat, you're on fire. We're going to discuss the correct answer when we come back from break. But you can ask any other questions if you want to during this break. It sounds like Tony Hawk Pro Skater, and it is on the same console that series released on, but it is not. I'll help you out. Does anyone recognize this game? I'm guessing no one does. Yeah, Jet Moto was a really great racing game. I'm surprised it stopped at the PS1 era. Yeah, this is Nier Automata. I feel like half our lectures are going to be DMCA'd. Fairies. I don't think, yeah, if this is being enforced, I don't think this would be considered super fair use, but... We'll give it another minute. So one thing I've wondered is, there are quite a few games that make up fictional languages for their dialogue or their music. And I wonder how challenging it is, one, for the composer or director to create this new language. I wonder how consistent most creators of these languages try and make the language. So, you know, getting repeating words and stuff where you'd expect to get repeating words. And then I also wonder the singers, the performers, I wonder how difficult it is to get used to singing in a fictional language. I'll bet you can find an interview on this topic somewhere, but I don't know of any. Okay, so let's go ahead and get back to it. So chat was on fire. They were completely right. Well done, team. Okay, so when you grab collectibles in most games, the act of collecting something usually is usually comes with very fluid motion. You don't like bounce or collide or physically impact the thing you're collecting, usually. You just kind of run through it. It disappears as if made of mist. And you increment the inventory, and there you go, you're good. However, this is not what was happening in the example that I showed you. In the example I showed you, we had collection working, but we had a physical interaction happening when the player game object hit the collectible game object. These things both had colliders, and I believe the sphere had a rigid body. I'm not sure if the collectible did. I don't think it did. But this is essentially what it looked like. You had a box collider, and it was not a trigger. It did not have its is trigger checkbox clicked. And the code for collection on the player looked something like this. You had a function on collision enter with a parameter collision other. And hey, it uses that incoming piece of data, that other data, to check what did I collide with, and should I increment my score and set that other object to inactive so it disappears, right? So this is very similar to how it was done in the tutorials, except you probably clicked that is trigger checkbox, yeah? And you probably didn't use on collision enter with a collision parameter. You probably used on trigger enter with a collider parameter, okay? If you compare this, it's night and day. This sphere just simply rolls through, has no physical interaction at all with these collectibles. It feels very smooth and satisfying. This up here is a little bit, it's a little bit rough. That is to say, there are two different types of colliders in Unity, and you can convert between the two by just checking this is trigger box. So a vanilla collider comes with physical interactions. Okay, this is sort of like the player interacting with the ground. You really don't want them to go through each other. You want that physical interaction there to prevent the player from going through the floor. However, for other things, you want to detect that a collision occurred, but you don't want to keep the physical impact of that collision. And that's what a trigger is. If you think about, if you think about every game under the sun, you've probably heard of things like trigger boxes. They're basically big cubes in the world where if you run into them, some piece of logic happens. A new wave spawns in Halo. A checkpoint snaps, right, in a Call of Duty. Stuff like that. Okay, a cutscene triggers. And so triggers are very, very popular. And so you get them by simply clicking this checkbox, and you have to swap out on collision enter for on trigger enter, and the parameter type as well. Otherwise, they work very, very similarly. Okay? Let's keep going here. Okay. There's kind of an elephant in the room. Unity is kind of a weird environment to program in, isn't it? Because, you know, if you think about it, the fact that main is a special name for a special function in C++ is kind of similar. So in C++, just by default, if you name a function main, that will be the first one that runs. However, or likewise, in Unity, if you give a certain function a certain name or a certain signature, name and a parameter list, then Unity will automatically make that function run at the appropriate time. Okay? You've seen this already with the start function. Capital S, start, no parameters, void return value. And that is a function that automatically gets run if that whenever you spawn in that game object into the scene. Same thing with update. It's a function that runs, 60 times per second every frame of the game. However, I believe if you make the U in update lowercase, or misspell any part of that, then it won't run. And that's a huge source of bugs as you get going. Accidentally misspelling the special names in Unity can be a big problem. So if some function just isn't being called when you expect it to, that could very well be it. Like one of your letters is lowercase when it shouldn't be. Okay. So yeah, update's an example of that. Start is an example of that. But you might ask, okay, what are the special function names that I can use in a component that I'm creating? Well, you can actually search that up really easily. Search Unity MonoBehavior, which is the class that you actually derive from in all of your scripts, if you've noticed, to create a component. And you'll see that these special function names are actually called messages. They're actually called messages, and you've got awake, you've got fixed update, you've got really cool ones like onBecameVisible, which is a function that will be called when an object first comes into view of a camera. I've got a question. It needs a collider. Can't we just not give the collectible a collider? If you don't do that, if you don't give the collectible a collider, then we can't detect collisions with it, ever. Like, nothing can. Because that object does not exist in the to the physics engine as soon as you get rid of that collider. The physics engine just doesn't know about it anymore. Yeah, so you can't use that. You could do something, though, where you just check the distance from the player, and if it's under a certain radius, in that effect, you've essentially written your own sphere collider yourself. So anyway, okay, let's keep going. Another thing I'd like to point out is that many of these functions that Unity gives you come with a parameter attached to them, or maybe sometimes multiple. This is when Unity wants to give you more information. What they'll do is they will pass in some sort of parameter with a certain data type. Now, if you've got code completion, you can just type the name, in this case other, hit dot, and it will show you all the cool things you can check on that data type coming in. In this case, we can use other to grab the game object that we collided with, and we can do anything we want with it. We could add a component to it, we could destroy it, we could set it inactive so it disappears. We can compare the tag to see, what did we collide with? Did we collide with the ground? Do nothing. Did we collide with the collectible? Get rid of it, add to inventory, Okay. There are a few interesting functions. You might have noticed that this is on trigger enter. Enter. Why enter? Well, this is a function that only ever gets called when you first enter into a collision with something. Okay? There are other functions that are similar but serve the complementary purposes. So there's onCollisionStay, which is a function that will execute and fire every single frame while you're still connecting to something, but not the first frame. Then you have onCollisionExit, which will execute at the one first frame in which two objects separate. Okay? So you can look at these three and see, whoa, there's a bit of a life cycle here. You can't use onCollisionEnter to know when two objects have separated themselves. And you can't use onCollisionEnter to understand if two objects are still colliding. Okay? And so you can use all three of these in a complementary fashion to essentially understand when collisions happen and the nature of them over time. Let me give you a quick demo. You have, let's say you have an enemy, okay, and you have the player, okay? Okay, this is sort of like that. Okay, and the enemy is headed toward the player. The enemy is headed toward the player. No function being called, no function being called, no function being called, onCollisionEnter. They stay together. onCollisionStay, 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 onCollisionStay. And then after like 30 frames, they finally split up. onCollisionStay, 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 onCollisionExit. No function called, no function called, no function called, no function called, no function called. Okay? I want to explain why this stuff matters. There's a very common bug that we'll be looking for in your P1. I want you to imagine that you create an enemy that can hurt the player by touching them. And the only collision function you remember to use is onCollisionEnter. So the enemy's coming, the enemy's coming, the enemy's coming, the enemy's coming. Boom! on collision enter, you hurt the player, you lessen the player's health, you decrease their health, okay? However, the player is really, really smart, and they decide that they're going to hug the enemy. They're going to hug the enemy until they've defeated the enemy. So the player won't let the enemy walk away. The player won't let the enemy get away. And because they never separate, on collision enter can never be called again, which means the enemy can't damage the player as long as they keep hugging. It looks absurd. The player might be hugging a lava monster, but they're not going to take any damage because you didn't implement on collision stay to check whether they keep colliding, okay, and dealing additional damage when they do. That is a very, very common bug that we see, and it's very funny, and we hope we won't see it much anymore. But keep this in mind, okay? Okay, there are a lot of functions out there. How do you find them without going to Piazza and asking us questions? You can almost always Google Unity topic, and you will find a lot of information, a lot of very high quality and standardized information on that topic very quickly, okay? Much faster than you can get help from us. However, if something still confuses you, come to us during office hours or ask on Piazza, okay? You can Google Unity model behavior. What's the difference between the functions? We just talked about those, okay? You can review this lecture if you want to. Okay, and you already know, we already talked about this. This is Unity's way of passing in data so that we can do more intricate and advanced logic depending on what happens, okay? Okay, cool. So I have a challenge for you, chat, and this is a pretty tough one. But this line of code is really powerful, and it's a really, really good technique for helping you orient and rotate objects without using any explicit rotation functions, which can be a little bit hard to reason about sometimes. What do you think this code does? And I'm going to show you a GIF. Chat, what do you think? Orients collider perpendicular to collidee. Well, yes, essentially, yes. When would you want to use this? Any idea? Have you ever played a game, like maybe a side-scrolling platformer that has slopes in it? And, you know, if a player is standing on flat ground, you want them to be straight up. But if it's slightly sloped, you want them to be leaning over a little bit, right? Watch this. So this is one line of code that gets us this really cool effect. As the player walks around, the collision that's happening at the bottom of the capsule triggers this on-collision stay function between the player and the ground. Now, this collision object actually gives us some really cool stuff, information. For instance, we can see, okay, what is the normal coming out of this ground at this collision point? And once we get that, we can tell our capsule, our player game object, that it's transform.up vector, right? The transform.up is a local vector that always points straight out of your character's head, okay? We can tell that up vector that it should be pointing in the direction of the normal, and that will it will rotate our game object and force it to respect that normal and orient it in accordance with the normal of the slope. So this is one really, really cool line that works really well. Yeah, makes colliding point of contact. Anyway, this is what it looks like without. Are you lagging? Can you hear me okay? I think you still have the explanation. I think you're fine. Anyway, this is what it looks like without without that line of code. So we're glad we have it. Okay, hopefully it'll be a little bit smoother going forward. I think my computer just had a hiccup or something. But that is essentially all I want to teach you about rigid bodies and colliders today. It can burn up some of your time if you get caught on one of the bugs relating to this, but hopefully now you understand that there is a difference between colliders and triggers and how to use them in their various functions, okay? Okay, let's go ahead and talk about coroutines. Coroutines is one of the most important concepts you can understand in Unity because it allows us to do asynchronous stuff. In other words, it allows us to tell code to just wait, okay? We write a block of code, and in that block of code, we can have some logic just hold off until some other operation completes. Video games are unique in that you often you don't want to complete the entire game simulation in one frame. Often you want to do a part of the simulation, wait a couple frames, do another part, wait a couple frames, check for something, wait a couple frames, right? Let the user have a chance to do something. However, this is very hard to do in many other circumstances, like C++. I don't think C++ really has an await operator. It does have threading, but anyway, let's keep going. So here are two really, really difficult things that you'll need to do when you go to do your project one, okay? And I think you'd be surprised how difficult these seemingly simple tasks can be. So let's go ahead and take a look at room and door transitions in these two classic games. Okay, so look at this, right? Very, very simple looking. It's a process that gets you from one room to the next. Now, hold on. This is actually what happens when you try and do this, okay? So the player is walking toward the exit. Invisible trigger, on collision enter, disable player controls, move camera, enable player controls, right? So, on trigger enter, disable controls, move cam, enable controls, okay? Fairly straightforward. You already know how to detect collisions with invisible blocks. In this right here, in this cell, there's an invisible block. When the player hits it, that invisible block has been configured to know that we should go west. It's on the west side of the room, right? And so we disable the player's control so that they can't walk away during the cutscene. We then move the camera over to the next area, and then we re-enable player controls. Easy, right? Well, not quite. As it turns out, this is pretty darn hard to do, and it can take some interesting thinking to get this done. I want to show you another example in Metroid just to prove that no matter what game you work on, you'll have to work extensively with coroutines. Okay. So Samus is running along, and she's about to get to a door. She shoots the door to open it up. Okay, on collision enter, disable player controls, move cam, enable. Okay. Do it again. Move camera, re-enable player controls. Okay. Cool. So this kind of thing, pretty much the same thing, is in both games. Now, you probably ask yourself, what's so challenging about this, right? It seems very simple. You have a player hitting an invisible trigger. You already know how to do that. Just turn off the mesh render, put an invisible block there with some code, on trigger enter, give it a collider, a trigger collider. You disable the player controls. You know more or less how to do that. You can use a public static boolean, maybe is player control active, set it equal to false. Within your player control component, just don't do anything if that boolean, that public global boolean, is equal to false. Move camera to next room over 2.5 seconds. That'll be tricky. And re-enable player controls. You just flip the boolean back from earlier. Okay? Yeah, you've already done this. You've already done these things as well. But this is tricky. Okay? So temporal mechanics that span multiple frames is tricky because when you write code, right, a list of instructions to do, those all will execute in one frame, okay? There's no way that we know of to tell some code to, hey, I know you're only halfway through that function, but why don't you just wait until the next frame to keep going, okay? Or why don't you wait 3 seconds and then keep going down the function, okay? That would be extremely convenient. That would allow us to write this code pretty easily to move the camera. So a few solutions come to mind. How about threads? Can we use threads? Can we launch a new thread and then block on it? Unfortunately, no. So Unity scripting is single-threaded. It does not allow you to use multiple threads. You can use something called thread.sleep to pause the thread that you're on, but unfortunately, this will freeze all scripting. This will freeze your entire game. So we can't use it because we want other things to be happening while our camera is moving. Now, await is a function that allows you to do something like this, but unfortunately, our C# version that Unity uses is not high enough, and they don't support it. So we need to use some other sort of solution, okay? Here's what we want to be able to write. Here's what we want to be able to write. On trigger enter, right? If you touch the door that leads to the west, you want to perform a transition to the west. This could be a function that turns off the player controls and moves the camera over some time, and then when it's done with that, after 2.5 seconds, it goes to this line and just re-enables player controls, okay? And the problem here, we really would love to do this because it's a lot simpler and easier to read and easier to understand than some other options. There are other ways you can do this. For instance, hold on a second. We could implement this using a state machine, right? And we wouldn't need to use any other fancy technology, but that tends to be very, very bug prone and a little bit complicated, and you can get a lot of bugs that way. So we need this to be able to pause for 2.5 seconds. This function right here, it needs to be able to pause for a certain amount of time while letting everything else run. So can't use thread.sleep, as we said. We're single-threaded. A poor solution that would technically work, and something I used to do a lot, was we would create a state machine class in which you have to create a new state, essentially, for every different thing that you wanted to do. It's a lot of work. It's error-prone. It can turn very buggy very quickly because you're writing a lot of code. It also becomes a little bit tricky to read. And so we don't really want to do that if we don't have to. So what we're going to do is we're going to use a built-in solution for this, coroutines, okay? Coroutine is essentially a way of taking a function and making it asynchronous. So that function that we wanted to have can essentially just be over here, right? So here is our coroutine. We know it's a coroutine because if you ever take any function in C#, like delayed hello, this looks like a function, right? If you take a function and give it an IEnumerator return type, then what sort of happens is this function gets turned into sort of an array. You can think of it as an array of instructions by the runtime, and it gets played piece by piece in a way that can be stopped, can be paused, can let other stuff run. So by putting IEnumerator here, we've turned this function into a coroutine, and we can launch that coroutine by using the start coroutine function, okay? And I have to ask, chat, your next challenge, chat, what do you think the result of this code will be? This is in a component called awkward hello. And so when the game runs and this component starts, what's going to happen? What are we going to see in our console? Bingo. Mopey's got it. We'll see a 3-second pause between hello and there. So what happens is start coroutine launches this coroutine, which is just a function call. Execution immediately goes to debug.log hello. So we see hello right away. Then we have an interesting line that might be a bit confusing. So yield return is not like a normal return. Normally, a return line, that keyword, means a function is coming to an end. However, yield return, you can think of it as a new keyword entirely. That just means yield to something else. So yield return, we're yielding to a special object. It's called wait for seconds. You can essentially think of it as another coroutine. we're yielding to a coroutine called wait for seconds that takes a parameter 3 that makes us wait for 3 seconds. 3 seconds later, our execution returns into delayed hello, and we write there. So it goes hello, there. Okay, it is pretty awkward. You wouldn't want to do that in public, I don't think. But I've got one much worse for you. Let's take a look at this example. By the way, all these examples are in the course repo. If you want to play with them, experiment with them, use them, go ahead. So here's an example for you. We have an awkward hello. This should be called super awkward hello. I'm going to give you about 30 seconds, chat, to figure out what this does. And this is a little bit more complicated. This is coroutines yielding to other coroutines. Okay, who's going to be first? The thing about reading code, it's amazing. I remember the days when it took me like half an hour to read through a page of code in C. And these days you can just do it like the blink of an eye. And I think a lot of it comes down to when you see a line that is very abnormal, something you're not used to. It takes a lot of memory recall and kind of it takes memory recall, and it takes some cognition on your part to just figure out what that line is doing, you know, and that kind of prevents you from thinking about what it does in the broad sense and how it contributes to the entire program. All right, we got some answers. Hello, and I say that because I read through this like lickety-split. It's very easy to understand, but it can be very hard when you're seeing this kind of stuff for the first time. Be slow. Okay, so we've got hello, 3 hms, and then over 3 seconds, and then a there. Bingo. Well done. Well done. Okay, so here's how it goes for those of you who don't quite get it yet. The game starts. This component has a start function called. That start function calls start coroutine. On this coroutine right here, execution immediately moves to line 14. We get a hello message showing up in the console when we run line 14. We then get to line 16. This is a yield return statement. So whatever happens, we know that delayed hello is going to be pausing here. For how much time, we don't know. Okay, this yield return launches another coroutine. What coroutine? The do humming coroutine, and with a parameter of 3 number of notes. Execution goes immediately into do humming. We then enter this while loop. Number of notes is 3, so it's larger than 0, so we go around. We put into the debug.log, in the console. We decrement that variable that came in, so now we're at 2, and then we wait for 1 second. After we're done waiting, we go around this while loop again. So we wait 1 second, we go around, print hum again, we go around again, wait 1 second, we go around again, until we get to 0. So we're gonna 3 times, and then this function escapes the while loop, it gets to the end of the function, the coroutine, and it ends. We now return to delayed hello. We're done waiting, and we move to there, okay? So it's hello, there. All right? So, yep, not too bad. It's not too bad when you go through it. Here's one that might be a bit nasty for you. Okay, if you thought that other one was easy, this one is not so easy. It's very easy once you understand what it's doing. However, it's very useful. In fact, this is something you could use on P1 right away, and you can use it. I believe it's in the repo. Okay. Team, I'm going to give you about 30 seconds to figure out what this is doing. And I recommend the first thing you do is you study this coroutine over here, because this coroutine is called twice over here. So Idomori, if you call start coroutine without yield return, then what'll happen is you'll start a new coroutine, but you won't wait for it to finish. And so you'll launch that new coroutine, and it'll start, but we'll continue on until we hit a yield, and then that coroutine we launched will execute. Remember, Unity is single-threaded, so if we launch that coroutine right away, it doesn't start processing until something yields and allows it to run. In other words, if you omit the yield return, then you do not block on that coroutine. You just cruise on by it. You start it up, but then cruise on by. Okay, team. Do we have any guesses for what this is roughly trying to do? And I'll give you a hint. It relates to one of the first things that we showed you in this lecture. When space is pressed, it will move object from current position to target position over 2.5 seconds, wait 2 seconds, then move the object back to the initial position over 2.5 seconds. Dynamite. Well done. Well done, China Bears. Good, good. It's a lot of code, but if you really look at it, it's actually a lot of functions that take a bunch of parameters. This is really one line of code, this entire block here. It's just formatted in kind of a sandwich styling, just to save a horizontal space so I could fit it all on one slide. Okay, so here's essentially how it goes. I want to first start by talking about this coroutine over here. This coroutine is really cool. It is a pretty generic function, the kind of which you might expect to find in a library, because it's very, very generic and reusable. It is a coroutine called move object over time. It's a coroutine because it returns an I enumerator. We could only move stuff over time within one function if it was a coroutine. So what does it take? And as far as parameters go, it takes a transform. This is your target, the thing you want to move. Okay? It takes an initial position represented by a vector 3 point in space, a destination position represented by a vector 3 point in space, and a number of seconds to do it across, represented by a float. What it does is it immediately figures out, okay, what's the current time? It then calculates a progress value, okay? And the progress value is the current time minus that initial timestamp, right? So this is the amount of time that has passed since we first started this function. Divide that by the duration we want to do stuff over, and we have a value that over the lifespan of this function call will go from 0 to 1. Numbers going from 0 to 1 is super useful. We can use that for a lot of different things. Okay? We then go into this loop. We do this logic until our progress meter goes from 0% to 100%. We recalculate progress every single frame, and we calculate a new position using that value. The vector3.lerp function may have confused you when you saw it, but what lerp stands for is linear interpolation. It's a very useful function. It takes two 3D points and gives you one in between those two based on the third progress variable that you put in, the progress parameter. So if you give it a 0.5, it will give you the vector 3 that is between your initial position we gave here and your destination position, okay? If we give it a 0, we get the initial position, and the 1, if we give it a 1 in progress, we get destination. So in other words, as progress goes from 0 to 1, this new position value, and as a result, the position of our target transform, goes from the initial position to the destination position, okay? And it does this until progress is 1, and then we put it at the destination, and we're done. We have moved a transform, which represents a game object, from the initial position to the final position over a certain amount of time. Notice also, though, another very interesting thing is that this is public static. This is really nice and convenient because you can now use it from any place in your entire code base. You don't really have to worry about access. You don't have to worry about instantiating anything. If you have too many of these, it might start to cloud up your namespace, become an organizational issue. But for the size of the projects we'll be making, this is not a big deal. So we use this coroutine in two places over here in our component. Okay, this is our library function that we reuse, and we can reuse it any place we want, really. Anytime we want to move something over a certain amount of time, it's perfect. Okay, so what happens is the game starts, our component start function launches, start coroutine causes this wait for player input to transition coroutine, very specific name, to launch. We then enter this while true loop, okay? This is an infinite loop, and there's no breaking in here either, is there? This infinite loop waits every single frame. It does a yield return null, which essentially says, okay, yield until the next frame. Don't yield for 3 seconds, yield for 1/60th of a second. Let everything else run and then try again. So this waits for the player to press the spacebar. It then grabs our initial position, which is just wherever this game object currently is. Whatever game object we put this component on, it's going to consider that initial position. We then have a hard-coded final position, which is just, 20 units to the right. And we then yield return until that coroutine is done. We send our transform, this game object, from the initial position to the final over 2.5 seconds. We then wait for 2 seconds, and then we bring it back. This function call is simply swapping the initial position and final position to get it to reverse what it did earlier. And the result is this. You press spacebar, your camera moves over here, and then it waits 2 seconds, and then it comes all the way back. Okay? So this is essentially what you could use, the technique you could use to move your camera over and disable and re-enable player controls. You just need to mix up the code a little bit. Some questions? Floating point precision is the only, doubles are really not friendly with Unity. Essentially all of Unity's API calls want floats. They are, I believe they're half the precision of doubles, and this is done for performance reasons. A lot of engines do this. Star Citizen famously got into trouble for this because they're trying to represent a galaxy, just a massive amount of space. The problem is, if you represent a character's location with floats, then as their coordinates get bigger and bigger, right, in this huge continuous world, you lose precision. So weird things start to happen. Your characters start to jump around and stuff, and it doesn't work well. So they had to rework their engine to use floats instead. It hurt performance, but floats were really nice. Oh, anyway, that's why Unity uses it. So, yeah, this is really, really effective. And while this might be confusing, the fact that you can write it once and reuse it anywhere and it just works, it's something you can block on and it does what you expect, is really, really powerful, okay? So I encourage you always to think about, okay, I'm writing this function, but what if I could make it as generic and reusable as possible, okay? Oftentimes you write logic that is actually, you can use it in many different places, and doing so will cut down on the number of bugs you have and lessen the amount of code that you have to write too. Makes maintenance way easier, and we'll talk about that more in the future. Here's another example of a place where coroutines could be useful on Project 1. In Zelda, you often have to defeat all the enemies in a room before the room's door will unlock and you can proceed through. I think actually there's one room in Zelda that does this that you'll need to implement. Here is a coroutine that is a while loop, an infinite loop, that checks to see if there are any enemies left. It will stay in this loop and keep blocking until that is no longer the case. So the first thing it does is it uses a cool function, GameObject.find game objects with tag. This will grab you all of the game objects that have a certain tag, throw them into an array, and you can turn that into a list later if you want to. It then checks how many are in this array, how many enemies are still around, and if there are no more enemies left, it breaks out of this while loop, this infinite loop. Otherwise, it says, okay, well, we're not done yet, so we need to let everything else run, and we're going to yield return null. We're going to wait until the next frame. We're going to check again, okay? Question, what would happen if we got rid of this yield return null? what would happen, team? We're going to get rid of this yield return null. Bingo. Bingo. Jelly Kid Forever got it first. It would never yield back control. It wouldn't yield back control. So remember, Unity is single-threaded, and this is still the case. Coroutines obfuscate this fact by allowing you to do stuff that is asynchronous. But in reality, Unity scripting is still only single-threaded, and it will not let other stuff run. If you are executing at a point of execution and you never hit a yield, you never hit a yield return, then you're going to just keep going until you hit one of those. In other words, we would never be able to break, okay? Because we would continuously just keep checking the current state of the game. We would never let enemies move. We would never let the player attack, so enemies would never go down to 0. We'd be stuck here forever, infinite loop, okay? You'll know it when it happens in Unity. It's not very fun. You have to kill all of Unity, unfortunately. Okay, so here's another example. This is an example that moves an icon on your UI. It moves it to a certain location. So I don't really care about that too much, though. The question is, the following code has a problem. It's going to be a disaster. As soon as you hit play at the top of your Unity editor, your entire Unity editor will freeze, and you'll be very confused. Why? What's the killer line here? We got Mandelbrot. So for yield return null, on the next frame, does it pick up again on the yield line? Yes, it does. Yeah, it picks up right after that line. So where's the issue, team? Where's the issue? This is a hard one. This might be the hardest example in this entire day, this entire lesson plan. I'll give you a hint. It's something to do with that while loop. The while loops are dangerous. Bingo. Phantom fan. Got it done. Okay, so here's what happens. When we get into this progress loop, this while loop, everything is going pretty fine, right? And the idea is that progress is a value that's going to keep heading up toward 1 and beyond 1 as time.time gets larger and larger. As time.time gets larger and larger and further away from that initial timestamp we took at the beginning, progress goes higher and higher. And then after it gets past 1, we break out of this loop and we're done with this function. We're all good, right? Success. That's not going to happen, though. Okay, here's what happens. When we get into this while loop, we immediately calculate progress, and then we immediately move that icon on our UI to make it do a cool animation. However, as soon as we hit the end of this while loop, we have no yield. We haven't been told to yield, so we're just going to go around again right now. Right? We go around again, and the time system in Unity, other logic in Unity has not had any chance to run at all. So time.time is the same value that it was the last time we iterated through this loop. And then the next time we iterate, it'll be the same value, the next. The problem is progress never actually gets bigger because time.time never gets bigger because all of Unity's other systems, including the time system, which makes this go forward as a value, hasn't been allowed to run since you never yielded. So putting a yield return null right here solves the problem and makes it work, okay? No more infinite loop, you're golden. Okay, so coroutines are extremely powerful. I saw earlier that they're coming to C++, or maybe they're already in C++, which is really cool. It seems like the committee's been very aggressive with adding features to C++ lately, which is kind of neat. But coroutines are very, very nice once you get the handle of them. So much of what we do as game designers we implement things that happen over time, over multiple frames, right? A cooldown doesn't cool down in 1 second, right? It cools down over a certain amount of time. A cutscene doesn't move the camera here to show this, move the camera here to show this, and then move it back all in 1 frame. It moves it to this position over a course of 30 frames or more. It moves it to this other position, moves it back, and then moves it back, right? And then has to enable and disable player controls. And so whenever you have a sequence of logic that needs to play out over a certain amount of time, your brain should instantly go to coroutines. You don't always need to use coroutines, and it's not always a great idea, but they can be very, very valuable, particularly in instances where you need total control, a prescribed sequence of things that must happen, like a room transition. Step 1, disable player control. Check. Step 2, move camera, move player to new area. Check. Enable camera controls. Check. Enable player controls. Check. Spawn enemies. Check. Right? So, anyway, that is coroutines. I encourage you to look into the repo where you can find examples and play around with these if you get confused, because they're just super important. Okay, we got about 1 minute. Next time, on Wednesday, we'll be going through one of my favorite lectures, composition. The idea that there are alternatives and complements to inheritance as far as code reuse. The idea that you can create really, really interesting and customizable entities out of taking a toolbox full of components that you've created and mixing and matching them. Oh, okay, okay, I'm going to put the isFrozen component onto this enemy to see what happens. Oh, it just melted near the other enemy that has an isFiery component, right? We're going to be playing through Scribblenauts a little bit, which is a fantastic game that allows you to bring any game object into the universe, into the game world, if only you can type its name. So if you need an apple to solve a puzzle, you just type apple. If you need a bicycle to solve the puzzle, you just type bicycle. And the game was made by a small team of like 50 people. So we'll be discussing the inheritance and composition approach that allowed them to do all of that, create literally any object known to man, essentially, and bring it in to the game for puzzle solving. Anyway, it's going to be an awesome time. It's the lecture that got me my job here at Michigan, so I enjoy it quite a lot. Thank you so much for bearing with my dying voice here. And I hope you will take the next couple days to relax and prepare for the launch of Project 1. Thank you all so much for joining us. I'm going to stick around for about 5 minutes. If you have any questions, please let me know, and we can get those solved for you, okay? I'm going to throw some music on, and then I will see you all later, okay? Take care. How are you feeling, everyone? I'm feeling... We did that. Okay, this is let me see if you can get this one. This one's also a classic. You definitely know this franchise. I'll give you a hint. It's not a game franchise, but this is a game, and this is a great song. Let me do... Okay, go for it. We'll cover input management. It's not a huge deal. I don't think it'll trip you up. The main thing to think about is what's the difference between input.getKeyDown, input.getKeyUp, and input.getKey. This is literally analogous to on-collision enter, on-collision exit, and on-collision stay. Input.getKeyDown will be true for the one frame in which you first press the key. Input.getKeyUp will be true for the one frame in which you release the key, and input.getKey will just tell you whether or not the key is down or up, any frame, right? Every single frame. This is not Castlevania, though I can see why you'd say that. I think it has a little bit too much energy for Castlevania. It's a little bit too fast. Any questions, chat? All right, I'll reveal the song. Okay, so yield return works with other coroutines. It also works with specific objects. I can't remember exactly what they're called. Progressible objects, I think. And that is what the new wait for seconds object is. If you go and you look at the wait for section, or maybe it's yield instruction. If you go and look up yield or wait for seconds, you'll find that it's a data type that has been created and has a particular interface that allows it to basically decide when it has finished, which also allows the coroutine to wait on it. So you can create your own kind of data objects that do this too, that allow you to yield on them and then give up that yield when they're finished. But yeah, yield return will not work with like normal functions. It must be a coroutine. The issue is that normal functions have no capacity at all to actually delay over time. And so it wouldn't make much sense to yield on them, since you'd immediately do that function and immediately come back. In fact, it's interesting. If you mark a function as a coroutine, by putting IEnumerator as the return type, but you don't have any yield statements in it, then the compiler will be very confused as to why you didn't just make this a function. In fact, it won't let you keep it as a coroutine. It will force you to just get rid of the IEnumerator until you put a yield statement in. Okay, that's been about 5. All right, thank you again, everyone. I hope you have a fantastic couple days and a great second week here of the semester. We will see you again on Wednesday. It's a very exciting time. We'll get P1 going. Oh, we're going to learn so much. All right, we'll see you then. Take care, everyone. Bye-bye.